Alright, here is the first video on chain rule worksheet. So find the derivative of the following functions with chain rule. Remember to use chain rule. This is like a chain rule practice, so this worksheet was made for chain rule purposes only. Ignore this part, the second part of the instructions. First question is y equals 5x squared plus 3. So this is the function, like this is the whole function, to the power of 1/2, or 5x squared plus 3 all square rooted. Okay, so like I mentioned, this inside part is like, you can consider that like a whole function. Like if it was x to the 1/2, then by taking like a derivative you would do power rule. So y prime equals 1/2 come out, and then x to the power of 1/2 minus 1 is negative 1/2. So it's 1/2 to the power of 1/2 x to the power of negative 1/2. So that would be the chain rule, or not the chain rule, that would be the power rule. But then by using the chain rule, since we have a non-x here, non-x inside, we need to use the chain rule. So y prime actually equals 1/2, same thing. So 1/2 in the whole function, which is 5x squared plus 3 to the power of 1/2. But then we still need to take the derivative of the inside and multiply it with the previous one. So the derivative of 5x squared plus 3 is 10x. So 1/2 times 10x equals 5x, and then multiplied by 5x squared plus 3 to the power of negative 1/2. To get rid of the negative 1/2 exponent, we need to do a fraction. So 5x times 1 over square root of 5x squared plus 3, which is equal to 5x plus square root of 5x squared plus 3. 5x over square root of 5x squared plus 3. So this is our derivative answer. So that was the chain rule. I think this one's the easy one. And the second one is a little bit more complex because it's trig. But it's also not too bad. So y equals this function. This part is actually sine 6x plus 9, and that whole thing is to the 5th power. So this is like the inside function, the sine 6x plus 9. So like before, we're going to consider it as x. So y equals x to the 5th. So y prime equals 5, come out, x, and then 5 minus 1 equals 4. So 5x is 4th. So this would have been this is basically a shape of this function, but then it's a little bit more simplified. So instead of x, we're going to put y prime equals 5 times sine 6x plus 9 to the power of 4. But then since we have the inside function here, we need to take the chain rule. So derivative of sine 6x plus 9 is cosine 6x plus 9. But then here, we can see that we can still take the derivative of the inside, which is 6x plus 9. So derivative of 6x plus 9 equals 6. So the answer is 30 sine 4th 6x plus 9 times cosine 6x plus 9. Okay, so it might be a little bit confusing as to why we need to take the derivative one more time with the 6x plus 9. So if the function was cosine, like x, let's say, cosine x, then we don't need to take one more derivative, because if you take the derivative of this, then obviously we would get 1, which is the same thing as just cosine x, right? But then the inside is 6x plus 9, so cosine 6x plus 9. But then when we know that if we take the derivative, you get 6, so it's no longer the same as 6 cosine 6x plus 9. So originally we were like, obviously, let's just say that we were supposed to take the derivative here, but then the derivative doesn't matter because the derivative is 1, but then no longer is 1 in cosine 6x plus 9, so that's why we actually like take the derivative. I mean, you can just think of it as like, we always take the derivative whenever there's a function inside a function. You can see like x is inside cosine x, so I guess that could be a function inside a function. And then here too, because there's a function inside a function, 6x plus 9 is inside cosine x, so we're taking the derivative, and then the derivative of 6x plus 9 is 6, so we need to multiply that with the original function of cosine 6x plus 9. yeah, so I think as you guys like follow along, it'll be easier for you guys to understand. But for now, we're gonna move on. The next one is a little bit more complicated, I would say, but as long as you understand the chain rule, I think it'll be fine. So next question, we're going to be multiplying 5x squared plus 3, this whole thing, times tangent squared, 7x. For first thing we need to do is to use the product rule. So this is going to be one product number 1, and then product number 2. So y prime equals the derivative of the first one, which is 10x, and then just multiply the second one original, so tangent squared 7x, and then plus derivative of tangent squared 7x. So tangent squared 7x is similar to the one before, so it's tan 7x to the power of 2. So we need to take the derivative of this one, which would be 2 come out, and then tangent 7x, right? And then there's one less power, so it's just 1. And then you have to take the derivative of tangent 7x, which would be secant squared 7x. And then again, we can see that there's an inside, which is 7x. So we need to take the derivative of 7x, which would be 7. So that goes to the front. So 14 tangent 7x, and then secant squared 7x. So that would be the derivative of tangent squared 7x. So first we're going to do 14 tangent 7x, and secant squared 7x. And let's not forget the original first one, which would be, let's move this a little bit. And then times 5x squared plus 3. So this would be our answer for the third question. Alright, let's move on to the fourth question. So the fourth question might seem a little bit daunting at first because it's so many like radicals and fractions, so many complicated things, but we can try to simplify it a little bit. So y equals 6x squared plus 4, 5x plus 3, and then this whole thing to the power of 1/2 since it's square root. So whenever there's like square root, we can try to simplify it to like an exponent so it becomes easier. This isn't the case for all the problems, but this is usually how it goes. So if there's like a radical, just try to change it to an exponent to make it easier. Alright, so we can see that this is like a simple power function if you think of this as just x. So x to the power of 1/2. So y equals x to the power of 1/2. Y prime equals 1/2 x to the 1/2 minus 1 equals negative 1/2. So it's 1/2 times x to the negative 1/2 power. So this will just be the same thing, or similar. Y prime equals 1/2 times 6x squared plus 4 plus 3 to the power of negative 1/2, but obviously, like we did before, there's an inside function of this one. So we need to take the derivative of this one, which we need to do using quotient rule. So let's take derivative somewhere else. Let's take this right here. Let's just make it a separate function, like y equals, I'll just do f of x for notation purposes. And then 6x squared plus 4, 5x plus 3, f prime x equals the top one derivative, which is 12x, and times 5x plus 3, the bottom one, original, and then minus. The bottom one derivative is 5, and then top one original is 6x squared plus 4. And then we're going to do a division. Bottom one original to the power of 2. Right, so this is how you take the quotient rule, and then let's try to simplify this just because it's a little bit too complicated. Let's see. 60x squared plus 36x minus 30x squared minus 20 over 5x plus 3 to the power of 2. Okay, I think this is right. So, which is equal to 30x squared plus 36x minus 20 over 5x plus 3 to the power of 2. Alright, so usually I think we have to get rid of the negative exponent, but right now it's a little bit too complicated, so I think we're just going to leave it like this. So y prime equals, coming back here, 1/2, and then 30x squared plus 36x minus 20 over 5x plus 3 to the power of 2. And then, yeah, just a negative 1/2. Yeah. Each teacher has like different, I would say, rules for negative exponents and notations. Make sure to ask your teacher for what they prefer so that you know how to put your answer in the right format on like tests and exams. Okay, next, 5th question. We've done 4 already, so great progress. So 5th one is y equals ln cosine 5x to the power of 6. So, I think the purpose of this problem, since it's not parentheses here, I think it's just going to be cosine 5x to the power of 6. So, yeah, this is inside. Yeah, I think this is how it goes. Yeah. So, basically, you know how, like, there's, like, ln x, right? Y equals ln x. So, cosine 5x to the power of 6, that would be the x here. So, yeah, that makes sense. So, derivative of ln x is y prime equals 1 over x. This is a memorized formula, so everyone should know this. If not, I think you'll probably learn later, but yeah, that's fine. And then, yeah. So this is how it goes, but then y prime equals 1 over x, which is here. So cosine 5x to the power of 6. So that is, well, before chain rule. So, like you know, we need to take the chain rule again. So there's the derivative of cosine 5x to the power of 6. So for that, we're just going to take it right here. So derivative of this would be, again, the power comes out to the front, which is 6, and then cosine 5x, and then 6 minus 1 equals 5, so 6 cosine 5x to the 5th, and then take the derivative of the inside, which is negative sine 5x, and then one more time, there's the 5x inside sine x 5x, so we're going to do derivative of that, which is just 5, so that also comes out to the front, so 30 cosine 5x, also negative. This is not cosine 5x minus sine 5x, it's more like there's a negative sign multiplied to the sine 5x. So you have to take that to the outside, so negative 30 cosine 5x, and then multiplied by sine 5x. So that's the thing that you need to multiply to this, which is equal to negative 30 cosine 5x sine 5x over cosine 6 and 5x. Yeah, so this is the answer to the 5th question. We have 2 more questions left. The 6th one is y equals 5 sine to the 4th power, and the inside sign is e to the negative x. So, kind of similar to what we did before. Y equals 5, and then sine e to the negative x, and then this whole thing to the power of 4. 5 is outside. 5 is like a constant that's multiplied to this. Yeah. So leave it outside. And then just to start, let's see. So we're going to consider this as our typical x. So y equals 5x to the 4th power. Derivative of that is 20 because 4 comes out to multiply with the 5 in the front. And then x to the power of 4 minus 1 equals 3. So that's that. That's the form, I guess, of this derivative without chain rule. Let's see. So y prime equals 20. Just fit everything into this form. So 20 times, 20 times sine e to the negative x to the power of 3. But then this is before chain rule, so you need to multiply the inside derivative here. So derivative of sine e to the negative x. So first would be cosine, right? Cosine e to the negative x. But then we need to take care of the inside function of cosine, which is e to the negative x. So derivative of e to the x, f prime is e to the x. But then if the function is like that, derivative of e to the negative x is you need to take the, I guess, derivative of negative x, which is negative 1. So you need to multiply negative 1 to e to the x, e to the negative x. So derivative of e to the negative x is negative e to the negative x, which is like pretty simple. So multiply negative e to the negative x to this whole thing. So that is negative 20 sine 3 e to the negative x times cosine e to the negative x, which should be the answer for the 6th question. Alright, we have our last question here. Christine wanted to measure the dimensions for a birthday box that would create the greatest volume. She was originally using variable x as the dimension for the square-based box with equal height. But her teacher gave her a hint that it should be 5 less than the value of x multiplied by 3. Find the value of x. Okay. Basically, there is a birthday box that she's trying to make. Bad at drawing, but I think this is what it should look like. Let's see. So here is the same. So the height and the base dimensions are all the same. So she was originally using x for dimension of square base box with equal height. So these are all x's. But then her teacher gave her a hint that it should be. Okay, so volume equation is usually width times length times height, right? But in this case, width, length, and height are all represented by the same variable x because they're all the same length. So volume here would be v equals x to the 3rd power, or x cubed. And then this is like an optimization problem to create the greatest volume. So for this one, you would need to take the derivative of the v value to get the greatest volume measurements, or dimension for the greatest volume. But then apparently her teacher gave her a hint that it should be 5 less than the value of x multiplied by 3. So v is actually going to be 3x minus 5 to the power of 3. Yeah, that's the equation for the volume. So let's see how we can optimize. Okay, and let's take the derivative of this, which would be 3 comes out to the front. 3x minus 5, and then 2. But then the inside is 3x minus 5, so take the inside derivative, which would be 3. So 3 comes out again, so it's going to be 9 3x minus 5 to the power of 2. So v prime is going to be like this. And then to find the dimensions for the greatest volume, we need to do v prime equals 0. So 9 3x minus 2 3x minus equals 0. So obviously then we can see that when 3x minus 5 is equal to 0, this whole thing would equal to 0. So 3x equals 5, x equals 5 over 3. So yeah, when x is equal to 5 over 3, I guess just 5 over 3 unit would be the answer. So when she makes the dimensions as 5/3 for both width, length, and for all width, length, and height, then she would reach the maximum volume. Alright, so I think that wraps up the first video. Thank you.